Good afternoon, everyone. I'm coming at this from a particular angle. Tridium is a global market leader in integration software for buildings. So what we do is with system glue, if you like, we link lots of things together. That means we can pull a lot of data from different systems that are in buildings and then get it up to the cloud or wherever it's going to be used by applications at enterprise level to manage buildings, portfolios, cities even. So very much the technology, the enabling technology, and we work through partners. So I'm not having any meetings today because we don't do any contracts. That's something our partners do. If you're interested in this, then I can introduce you to people who can help you with it. And we operate globally in about 70 countries. So what I want to talk to you about today is how we can use real-time analytics to make our buildings smarter in the way we operate them. Now, several other speakers have touched on this already, so I'm going to slightly overlap, particularly with, say, Steve Lambert, who did a very good talk from MCS, coming at it from the CAFM direction, from the facilities management side. So I'm coming from the other end, but we meet in the middle, and that's what we want to talk about, the convergence and the way things are changing in the industry. So just to talk a little bit about a number of topics, first of all, and I'm into jargon busting, so lots of acronyms. You're all coming from different places, and I hope I can explain, and if you already know the acronyms, all fine. But in business, you've got lots of software. In fact, a lot of business processes nowadays are computerized, the majority perhaps, and there's ERPs and CRMs and goodness knows how many other systems. Just so you know, in case you haven't come across that jargon before, or that one. And there's lots and lots of data stored by our organizations. And increasingly, people are actually doing some analytics with that and using it because it's mission critical, business profitability depends on it. So analytics is getting used and it's become a major buzzword. And rightly so in a way, because it is hugely powerful when you can manipulate the data, turn it into useful insights to run your business in a smarter way. Now, contrast that with facilities to some extent. Now, we can talk about analytics in facilities, but I think there's a lot less going on in facilities with regard to this. We have, again, some acronyms and different software used to help manage the facilities of the building side effectively. And again, we've got lots of data archived on hard drives, but not much analytics going on so far, in my experience anyway, and I'm happy to be corrected. If you're already doing this stuff, fantastic. But I think FM is lagging behind the business world in terms of its adoption of this computing technology of analytics. And there are far fewer players in that space doing analytics. We are, but it's new even for us to do that. So that's why I can say that. So I want to talk about something else briefly, Internet of Things, because that's another bit of jargon. IoT, everyone keeps mentioning. It's not a new term. It was originally coined by a guy called Kevin Ashton back in 1999. And if you look up in Wikipedia, you'll see a definition of it, which I won't bother to read because it'll be seen on the video. But that's just one way of describing it. But it's all about collecting data from sensors and devices and then connecting those things together, exchanging data. So there are lots of trends going on in our industry that have an impact on FM. I just like to talk about these four of them. Integration, by that I mean linking different systems together so they can actually have a conversation and share data. Convergence, which is more about applications and software doing more stuff instead of being very narrowly defined functionally. They're more multifunction and converging. So you have to buy fewer things. IoT, which is what I've just defined, but it is an umbrella term to talk about wireless sensors and includes a little bit of some of analytics and big data and a move towards having information fed up to the cloud where stuff can be done to it. Although I will argue that actually you can do a lot of analytics and that stuff can be done down on site. You don't have to send everything to the cloud in order to get some good improvements. So you could argue about it, but the goal or the route, the journey we're on is towards more integrated systems. That seems to make sense, having things talk to each other, be connected, and to have to buy fewer applications to achieve your business objectives. That seems like a good idea as well. But so how do we get there and how does that go? So first of all, integration and convergence. Well, what am I talking about specifically? In the facilities, in your buildings, you've got HVAC, another acronym, heating, ventilation, air conditioning. You've got lighting. You've got blinds and shading increasingly as both a good thing for lighting and environmental well-being, but also from an energy point of view. Irrigation, maybe not so much in the UK, but in some other countries. Power distribution is increasingly becoming intelligent, so you can talk to that. Metering, of course, is becoming more important with lots of identifying individual loads rather than just having one meter for the whole building. Alarming and reporting on things. Security and access control. That's increasingly important to identify and keep buildings secure. CCTV, fire detection, smoke dampers, water leak detection, standby generators, GPS, refrigeration, lifts, escalators, digital signage, and so on. And then there's the whole business applications. So that was just the facility side. Then you've also got meeting room booking, and you've got hot desk management, and you've got visitor management, space utilization, planning, asset management, IT infrastructure, document management, CAFM, energy management, sustainability reporting, and wayfinding, and catering management, and ERP, etc. So, you know, why would you want to integrate? Oh, well, okay. So there's a lot of stuff to integrate, and that is an interesting challenge in itself, which we can help you with, but hey, that's not what I'm here to talk about particularly. So what I do want to talk about, why you want to do this. First of all, if you've got real-time information, you've got much higher quality of data than if you're just working on day plus one or next month's report that's come to you. And if you can look at things in real time, then I think we can all mostly agree that that's a better way to go. And you can leverage what you've already got in your buildings. Many of the bigger buildings, particularly, that you may be responsible for, have already got some sort of BMS system, but the data is locked away inside that BMS because they're largely proprietary. They've not been designed to export that data very well, and we can help you with that. Why would you want to do that? To link asset use to control system for improved efficiency. Well, if you're take a room booking, if you know what the occupancy is of the meeting room, then you can know whether to turn the air conditioning on in that room, and if you don't have anyone in the building, you don't need to have the air conditioning on. Also, you can improve the way that assets are utilised. You can follow manufacturers' recommendations to get a better result, sweat your assets better, if you like, because you're basing your maintenance intervals on runtime instead of just saying, well, every 3 months we have a visit, just check it's okay. It's better to do it according to how much it's been used. And then you also can have impact on financial because you can depreciate your assets in the accounts based on usage, not just by age, which is actually, again, more realistic. And you can also avoid a lot of legwork and people making errors when they transfer information from one system to another system or from spreadsheets to software and so on. Doing things automatically is a much more robust way of running things. And then, of course, if you've got all this data integrated in one place, common databases, then you can apply analytics much more easily. Because analytics is about gaining insight from lots of different data sources and applying human reasoning one way or another, be it by rules or by machine learning or by artificial intelligence. But that analytics can only come about if you've got access to all the data in one place. So let me give you an example, a real-world example. Tridium is very pervasive in the North American market in commercial buildings, on lots and lots of buildings. And IBM have a product called Maximo, which is one of the biggest, I don't know if it's the biggest, but one of the biggest CAFM software pieces. So we have a driver between the two, so we can talk to the FM system, and lets you do two-way communication. So Maximo, which is tracking all the assets and has all the asset tags for all the items of equipment, can send that information into the BMS, so there's a synchronization there, so people who are maintaining the BMS can know what the assets are. And all the metering data can come from the BMS into Maximo, so it knows what the energy use has been, what the hours run have been, and so on. And then you can use open standards to achieve a lot of that, and scale it up, and also, that particular point, sorry, that is the terminology that the supplier of this particular driver, which is a partner of ours, is using. It's calling it the Maximo Integration Framework. But that's what it would look like on screen. Not going to get techie with you particularly, but that on one side is our screen, on one side is the Maximo screen, and you've got data between them. But that's just very briefly to give you an example. But there are lots of others that one could give of how this is beginning to happen now, that this tie-up between the FM side and the systems world, if you like, real-time systems in the buildings. I'd also like to talk about real-time analytics, which probably needs a little bit more time to dwell on. We are deluged with data. I've already mentioned it. Lots of data on hard drives, stored in the cloud. It's a tsunami of data, and the problem is that it's rather hard to find stuff. So we've got too much data probably already, and it's getting worse. We're getting more and more data. So how do you find things? And that's what analytics is about. And the key advantage, one key advantage of analytics, to go on from what I've already said, is that it operates 24/7. Once you've created some rules or you've set your artificial intelligence going so that it's looking at the data, it can do that 24/7. It doesn't get tired. It's not a limited skilled resource. It can keep going all the time. So it helps find the needle in the haystack. And it can look at things, it can identify patterns, trends, and things that you wouldn't spot. Human beings are not very good at analysing huge sea of data. We can't pick out stuff very easily. Sometimes there are some ways, depending on how it's presented, but the analytics programs that we can create can do that a lot better. And it overcomes what is a huge problem in FM, is there are not enough good skilled people to go around. I've had someone this morning moaning at me, not moaning at me, but I mean just moaning about how difficult it is to get the right people in to do this work, to make the right strategic decisions about FM, and make the right identification of problems when they come up and what to do about them in a sensible way. Well, if you can distill one person's expertise into a set of rules, which you can then roll out across your organisation, you've multiplied the effectiveness of the resource that you've got. So you still need the skilled people, maybe at head office or in one place or as a consultancy you bring in to set it up, but then you can let it run. You can't get, I'm not talking about 100% substitution here, but make a big help to your skilled issue on how you maintain buildings. And what analytics gives you is actionable insights, so that something you can do something about. And in fact, it can go one better than that, because if you link it up to the control system, it can, I thought I had another point there. It can actually make corrective action to actually make some changes. You can fix things straight away. So that really helps. Now, when we talk about analytics, what do I actually mean? There are different levels of analytics. So first of all, you've got descriptive analytics. What actually happened? Well, you could articulate that. You could have a user interface that made it a lot easier to understand what went wrong. More usefully, you've got a diagnostic analytics. Why did that happen? What are the reasons? What's the underlying causes? So the analytics program can go out and look at other things that were going on in the building. What was the weather like? What was the occupancy pattern? So when you've got a fault or an exception, what's going on around that? But then it can get cleverer and say, well, actually, I'm based on what's happened before and looking at the trends and it's been going on over the last 6 months, 5 months, the last week or whatever, it can predict what is likely to happen, which is more useful still. And then decision support is getting towards the ultimate goal. So what should I do about it? And then actually automate that decision, as I just mentioned, and take the corrective action automatically. Now, obviously, if it involves physically changing a faulty piece of equipment, well, software is not good for that. You need to get someone out there, but you can at least correct some things directly. So where does that analytics software live? Now, this diagram is showing you different levels. You've got the cloud. Everyone's talking about the cloud. What do we mean by that? Lots of computer services up in data centers that are hosting applications for enterprises instead of them having their own little data center and hosting it themselves. But it's a mixture. A lot of you have still got your own data centers, or certainly your facility software or your CAFM software is probably still living at enterprise level in head office, but it might migrate to the cloud depending on what the IT guys say. And then you've got lots of sites, and some of you may only have one building, others of you got hundreds or thousands of buildings. And then right down at the edge, you've got your sort of sensors and devices that are actually producing the data in the first place and monitoring things in real time. Now, traditionally, if you like, although it's not much of a tradition because it's only been around for, I don't know, 5-10 years or so, the analytics lives up at the enterprise level and increasingly now at the cloud level. But with the Niagara software that Tridium sells, that's the name of our product, we aim to be up here at the enterprise and up at the cloud, but we can also be down on site. And we think there's a role, not just if it's not our stuff, someone else's stuff, but it actually can be done down on premises level. And ultimately, we're working towards you can actually do some of the analytics down at the edge. I mean, to illustrate that, there's an interesting company from Israel called PointGrab, I think, or GrabPoint, that has cameras which use video analytics in the device. It looks like a smoke detector on the ceiling, and it's not. If it was looking at this room, it wouldn't be seeing your faces. It's because that would give a privacy issue. It's seeing you as people, and it can probably distinguish whether you're a man or a woman, and where you're sitting in the room. And that gives you a better quality of data than just having an occupancy detector which says, yep, there's someone here or someone isn't. So that's a whole rich set of data from some edge analytics. Yeah. So that's just to illustrate some of where we're going, that some analytics is rightly done up here. If you're benchmarking and analysing across all the portfolio of buildings that you've got, then clearly you need to do it up at the enterprise or in the cloud. But if you're doing some fault diagnostics on what's going on with your heating plant or the lighting system, then you just need to do it down here. You don't need to take it all the way up to cloud. So what are the benefits of having real-time analytics? Well, having live data, as I've said, is very valuable, and combining that with the history. So you're not just looking at the present moment, you're also looking at what's gone on before and making deductions based on that. So that gives you a deeper insight into the root causes and suggests what you might be able to do about it in terms of remediation, and then automatically triggering actions. So I've put that in again just to emphasize that I think that aspect of closing the loop on getting the data and then pulling it back down to the system to actually make corrections where possible. Now, if you're going to do analytics, you've got to make it easy to use. One of the problems with analytics in the business world and now is it can be very expensive to implement because it requires computer programming and custom development and so on. So one of the things you should look for is advanced analytics that doesn't require programming skills, and also something that's very open. Now, an API, another bit of jargon, application program interface. Software, if it's open, it means that you document how the hooks, so how you can get the data in and out, and therefore I think it's very important that the software has that, and also that it has some sort of capability to visualize and report on what's going on from the analytics. How does it actually work? Well, the first thing you have to do is collect the data, obviously, and what you do have to do is apply tagging. So that's a sort of colloquial term for metadata, which is you've got a value, say a temperature for this room. Now that's got degrees centigrade, that's what it's measured in, unless you're in America, in which case it's Fahrenheit. But it's more importantly, it's got a location, so it's in this particular main meeting room, which happens to be on the south side of the building at these coordinates. And then you need to know what it's connected to. So it's a temperature sensor that's connected to the air conditioning unit, if there was one. No, probably not. But the temperature sensor, so it relates. So you need to give the context of that piece of data. So that's just one simple piece of data, but it's got a lot of metadata. Now, a computer, we as human beings, when we see a temperature sensor, we see it in the room, well, we can kind of make a guess that it's connected to the air conditioning system over here, you know, and we can do that. But the computer program needs to be told very precisely what it is, what the context of that data is, and then it can make sense of it and do something with it. So tagging is absolutely essential to the process of analytics. And then you get the program to review and assess the data, and as I said, you look at the history as well as what's going on now, and then it comes to a result or decision based on some reasoning that you've programmed into it. And that's about making alarms smarter and about forecasting and looking at trends of what's going to happen next. So to contrast alarms, in building management systems at the moment, in all sorts of systems, what you tend to get is just, oh, I've got a problem, something's in fault condition, or I'm outside of take that temperature sensor in this room, oh, I'm 5 degrees above set point, shouldn't be happening, alarm. That's not terribly helpful. There's no intelligence to that. The operator has to think, well, why? Why? And then they've got to go through a whole process of working out why on earth it should be 5 degrees over set point. With analytics, it's going to let you get at really what's going on. So to give you a different example, let's look at energy usage. So in your building, you're probably aware that you have thresholds for maximum demand. If you go over a certain number of kilowatts, you get whacked with a penalty by the utility company in terms of a tariff. You get to pay more money. So if I'm using 70 kilowatts and it goes up to 71, an alarm would tell me I'm over the threshold. Not very useful. So what analytics is going through the process that an engineer would have to go through when they were looking at that data and say, well, okay, well, what's going on? So how many hours has that happened in the last 6 months? That would be useful to know. How long did that happen? You know, what was the duration of that? What equipment was going on? Why was it doing that? Why did it go over? What was causing the problem? And then how was that related to the occupancy usage and weather in the building? So I hope I'm giving a picture of what's different from just data and raw information and then the analytics process. So here's an example of using analytics in fault diagnostics. Now I'm going to, traditionally with FM, correct me again, you guys are the ones who do this, I'm coming from an outside here, but as I understand it, you get a BMS that generates the alarm, the maintenance manager or the FM guy who's looking at the alarm says, oh, I've got to decide what to do about that. Okay, well, it looks like there might be a problem over in that plant room over there. So we get a works order raised in order to get an engineer over there, or technician to go to look at it. So you then have to go to site or down to that department to look at what's going on and then make a diagnostic of what's happened. And then you have to say, right, well, this valve's faulty, I've got to get a new one. Right, come back, request and replacement, and then go back a second time to install it. If you use analytics and you automate the process and you link it up to the FM software, then the alarm can be generated, the analytics works out what the problem is, that you've got a faulty valve, and then the works order is raised automatically because you've linked it through to the FM software, so you can get the replacement part out of the spares department, and the engineer has it when he goes to the site to visit it and repairs it one time. So you've saved a visit, and you've also saved skilled intervention to work out what the problem was. So I'm going to give you a specific example here. Now, I don't know how many of you are familiar with this, probably not. This is a schematic of an air handling unit. So you have ducts and you have fans. In this case, we've got a supply fan here. It's pulling fresh air in through a heating coil and a cooling coil. So you've got the ability to control the temperature here of your spaces. Sorry, these are in Fahrenheit. This is an American example. And this particular one, oh, I've got the heating valve is closed, it says 0%, so that's closed off, that's fine. The cooling coil is open, 78%, so that's good, it's cooling, and it's maintaining a supply temperature. All looks good. And if you look to the graph, well, that looks fine. But if you look a bit more closer with an analytics rule, you can say, well, I'm going to compare that temperature sensor to that temperature sensor. Oh, hold on a minute. This is different from this one. But that says there's no heating going in, so there's a problem because the system is lying to me. The BMS system is lying to me. It's saying that valve is closed, but actually it's not because it's letting by. You've got a faulty valve, and this is a very common problem that the valve gets stuck basically and it won't close completely. So what's happening here? You're heating up the air and then you're cooling it straight back down again. So you wouldn't know from a comfort point of view because comfort conditions are fine, but you've got an energy penalty here. And that's going to be wasting you a lot of energy. So analytics can spot that, and and even better, it can then have, if it's linked up to the FM system, it can know the asset tag of that valve, so it then knows what model and type and a valve it is, so that the engineer can go and get the replacement out of stores and go directly there and replace it. So the value proposition is know what you need to know and when you need to know it, let the system take the corrective action when possible, and report results, and smart alarms, something that's intelligent rather than just dumb So how would you go about doing that? Well, I've already said that you need to find you need to have at least one skilled person in your organisation to set things up and get the analytics organised. And you wouldn't do this all at once, you can't. I think you do it use case by use case, and you start eating into and improving the productivity of your maintenance approach. And then you're creating algorithms and then running those on the data and sending the analytics results to the works orders and management application. So that's the process in terms of software. That's the logic, what it would look like. There's what it looks like in our software as an example. And then you configure alerts, you decide what buildings you want to apply to. And at the end result of that, we won't worry about that, as you get leakage of hot water in hot water valve detected may cause a rise in energy consumption for this zone. So, you know, there's all that techie stuff, but at the end you get something intelligible that you can do something about. And equally in space utilization, this is more Deborah's field really, but you know, you don't know how many desks are being used each day for how long. Could have an IT application recording the login times, but that's not really great because they could log in and then go off and get a cup of coffee or go and have a meeting and you don't know that they're not using the desk for 3 hours. But it's really useful to know what the correlations are across multiple users. And so there are a whole new breed of systems coming on, such as from Condeco and there's others by Yancey and others, and MCS mentioned one, which are wireless sensors that you put under the desks and they go back to a gateway which goes directly to the cloud, and then you can work out how get more useful information about your hot desk utilization. Now that, of course, is a solution for one particular thing, but that needs to be linked up to all the other stuff that we talked about, particularly the closing the loop again with the environmental conditions. So if these hot desks are in a particular zone and there's nobody on any of the hot desks in that zone, well, you can change the set point on the aircon or dim the lights down or whatever, because you can save some energy there by knowing that that part of the building is empty at the moment. That's the integration over there I'm showing, and then the cloud management, and then sharing the data with other apps. And increasingly, and another bit of jargon, this is best done with web services. Historically, we've tended to dump everything into SQL and then pull it back out again. But that's a little bit clunky. It's better if you can do web services, and REST or SOAP are the two acronyms that you need to know there. As long as the software they both have an API, it's not difficult to write a connection to them. So you just write a connector or a driver or an interface, whatever jargon you want to call it. And the advantage of that, real-time data on building utilization. Combine it with logged-on status so you get more information, and then you can do the closed loop of adjusting the BMS, and ultimately you can then optimize your building space. And process the data to identify the issues and flag the exceptions. And of course the multi-sensors, they don't just have to be occupancy. I mean the Yancey ones, I don't know about Condeco, they've got temperature and humidity and other sensing and noise sensors in there as well, so you can use it for other things as well. So in summary, I just want to say that all of this stuff is getting cheaper, it's getting a lot easier to deploy. The pace of change in the sensor end of things is quite dramatic. The problem someone mentioned in an earlier talk about the issues of cybersecurity. One of the things that I think is really important about this is that there is encryption in the comms between these systems. In buildings up to now, there hasn't been a lot of encryption going on, and it's very insecure. Needless to say, what we do is encrypted, and these IoT solutions need to be encrypted as well, and there are ways you can do that, and some of the systems at least do have full encryption end-to-end, very important. So that's what I mean about increasing sophistication of those. And then siloed applications are converging. Well, I say they are converging. They could converge. The technology is there, but how many people are actually doing it? There's a need for more initiative to actually make this go forward. And then the analytics helps you with energy optimization, fault diagnostics, and space utilization. And ultimately, you can then run your building more cost effectively. So that's all I wanted to say. And have anyone got any questions?